Okay, so we're going to talk today about how we measure energy and power and what those things are. There's several kinds of energy. So the energy the car has because it's driving down the road, or that you have when you're out on a run or something like that. That energy of motion is called kinetic energy. Chemical energy is the kind of energy that's stored in bonds between atoms and molecules. So when you burn a piece of wood, what's happening is that chemical bonds are breaking and releasing energy. Same thing happens when you eat food. There are chemical bonds that your body breaks to release energy, and if you burn something like gasoline, it's the same general idea. Gravitational potential energy is the energy that something has because it's up off the ground. So if you were to hold a ball or something out of a window and you let it go and it falls, the energy of motion, or kinetic energy, comes from the gravitational potential energy that the ball started with. Nuclear energy is like chemical energy in that it comes from bonds. But in this case, it's bonds between particles inside a nucleus, not bonds between individual atoms and molecules. And those bonds, nuclear bonds, are much stronger than chemical bonds. And so when energy is generated through nuclear processes, it releases much more energy, but it can be very hard to control. There's a bunch of different ways to measure energy. The one you're most familiar with probably is calories on a food label. Technically, it's actually kilocalories, so when it says 100 calories on the label, it's really 100,000 calories. I'll just refer to those as food calories. In a physics class, the unit that's usually used for energy is something called a joule, because it happens to be a convenient amount of energy for the kinds of experiments you would do in a physics class. The way that power companies typically measure energy is in kilowatt hours. It's sort of a weird unit. We'll come back to it again in a second, but conceptually, it's just a separate way or a different way of representing how much energy is in something. Power refers to how quickly you use energy. So if you use some amount of energy in some time, you take the ratio of those two, and that gives you the power. And we'll come back to that in a little bit when we talk about the lab. Power is measured typically a couple of different ways, either in watts, which is the energy unit joules divided by a time in seconds. If you look at the charger for your phone or your computer, that sort of thing, there'll be some sort of indication on there of how many watts the charger provides. Another unit for power is kilowatt hours per day. So remember, kilowatt hours is an energy, and a day is a unit of time. And that's the unit the book is going to use, primarily because it makes the numbers that we're talking about a little bit easier to think about. They're not extremely big and they're not extremely small.